There are two things that we need to discuss before we start off doing numericals on second law of motion. The first one is your free fall, and the second one is about friction, because we are going to make use of this concept to do the numericals. I'll give you guys two scenarios. You guys have to come up with your own thought and thinking process and all of that, and come up with the answer which is under free fall. I have a small rocket falling towards the surface of the ground with the help of obviously the gravity and also a thrust at the back. So we have thrust and the push by the fuel. Okay, so this is your first case. Second case is a ball falling down purely under the influence of the gravity. You can read the definition, you can see all of it. You have to tell me which object is under free fall. Yes, object 2, that is the ball, is under free fall. Object falls only under the influence of the gravity. It is said to be under free fall. There are few facts about free fall. It is independent of the mass. What does that mean? All objects fall with the same rate. Let me give an example. We have an ant, say you, and a tank. Okay, it's vacuum. So under vacuum, you guys are let fall from a particular height. And what happens is you will fall in this manner, as if you are in a straight line. That line won't change. So all of you guys, all the things and everything on a surface which has no air or no fluid, if they're falling, they'll fall at the same rate, independent of the mass. Mass of an ant is much lesser than that of you and so on and so forth. It is independent of the mass. All of them will fall at the same time with the same pace. Okay, so free fall, it has a particular acceleration near the surface of the earth. It accelerates near the surface of the earth. The acceleration near the surface of the earth is 9.8 meter per second. What does it mean? You know acceleration, is it not? It's nothing but rate of change of motion. So the object will be increasing its velocity by 10 or decreasing by 10, depending on if you're throwing it up or it's falling down. So this value is fixed. It's changing the velocity at a rate of 10 meter per second square. Okay, so this value is fixed for all the objects, doesn't matter what it is. So in all the cases, what we are going to look at, it is in vacuum. There's no air in it. Okay, and the acceleration is 10 meter per second square. This is what you need to understand, right? So we'll be talking about free fall in the next chapter, so you'll understand that better over there. Okay, next thing that we need to know is about friction. Friction occurs whenever two rough surfaces are in contact and one starts to move over the other. This you guys know. What you need to know actually is it depends on the direction of the motion. Friction is always opposite to the direction of the motion. This you need to understand. And it's not dependent on the speed. Okay, so this is what you need to understand. Everything else is okay. All this is not required for you guys. So I erased everything else. So friction, it does not depend on the speed that the vehicle or the object or you are moving at, but it depends on the direction of the motion. If the direction of the motion is to the right, the frictional force is to the left. If the direction of the motion is to the left, the direction of friction will be to the right. That's all you need to understand and remember. Quite simple over here. And free fall is also simple. It's just that you need to understand anything under free fall has an acceleration of 10 meter per second square. It doesn't matter which object it is. We are not going to talk about what if there is air. That won't happen. We are just talking about vacuum scenarios, right? So very small things to be written, but it's going to be used. I hope you guys wrote both of it. Again, it will be used in few numericals, so please do copy it off.